Woohoo! Welcome back. Today we're going to be talking about solids of revolution. Yay! And my friend Lowly Worm is still here with us, and he knows all about revolutions, except we're going to be doing revolutions in a slightly different way. So I've got a visual aid. I know, it's very exciting here. Okay, so our example today, for which I have spared no expense, asks, what happens when you take the area bounded by x equals 0, x equals h, the x-axis, and the line y equals r, and you rotate it about the x-axis? Which now, again, if you just read it, if you're very, very lucky and your brain works in a very particular way, which some people's do, you can say, oh, yeah, okay, yeah, I can see exactly what's going on. I think most people read that and it's just blah, 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 blah. So let's do our best to draw a picture. So again, I'm in this weird world where I'm taking a two-dimensional set of axes, so the x and y axis, and I say I want to take the area bounded by x equals 0. So this is x equals 0. It's sneaky. That's the y-axis. X equals h. So that's right here, I'm going to say. So this x equals h. And here, just to make it easier, I'm assuming h is positive, but you could do this on the other side of the y-axis if you'd like. You get the same results. The x-axis, so that's this right there. I feel like I should be underlining this. Let's see if we could do that. I've got the x equals 0, so that's this guy. And then x equals h. Problem is I have limited colors, so I'm not sure if they will all be distinct. The x-axis, which is right here, and then the line y equals r, which again, we're not told how big this is, but I'm just going to go ahead and say it's right there. So this is the line y equals r. So for example, this point right there, that's the point 0, r. This, of course, is the point 0, 0. This is the point h0 right here. And this point right here is when x equals h and y equals r. Okay. So what's the area bounded? And the area that's bounded by all four of these is this. So it's a rectangle. And we want to take this rectangle and rotate it about the x-axis. Now, rotate means something in particular. So now I've got my visual aid. Ooh, so here's a similar rectangle. And what does rotate mean? It means you take it and you turn it, you leave it touching the x-axis, and you have it go around like that. And then if you imagine, if we go to the other side, it would keep going around. I did not make one that works 3D, unfortunately. Does that make sense? So it comes around and it goes around. Ooh, that would be a good expression. And what shape is it making when it comes around and it goes around, when it comes around and goes around like that? And what I'd like to convince you of, when it comes around and goes around, it's actually drawing out a circle. So what does that look like? Pardon me, Lowly Worm. He knows all about circles. So what we want to do is we want to rotate about the x-axis. So there's my y-axis, there's my x-axis, and so this little guy is going to go, remember how to do this. Perspective. My art teacher was named Mr. Jang. So hopefully Mr. Jang is happy with my recreation of trying to know a little bit about perspective and what is visible and what is not. But maybe we just don't tell Mr. Jang about this particular picture. So do you guys agree with me? Does that make sense? Here is that original piece that's sitting here, this rectangle. And I claim that if we take it and we rotate it around, we end up with this can shape again. This point goes around like this. Does that kind of make sense a little bit? So we're rotating it about the x-axis. Now, we could also rotate about the y-axis. Then it would go around this way instead of going around this way, if that makes sense. So we've got this lovely thing, and then suddenly we're like, oh my gosh, we're back to our friend. This is the right cylinder. And we know how to do that, right? Because we know that this height from over there, this right here is R, is the radius of the circle. And we know that this dimension right here, we were told was H. And so we know that the little, the cross sections are going to be circles, right? The radius is R. And then if we make them little chunky, give them some width, there's our delta X, then we know that if the area is going to be pi r squared, and we know from doing this before, the volume would be adding all of these up, we'd get pi r squared times the dx, which is the delta x, right? And we go from 0 to h. This is exactly what we were doing in the previous video. So this is going to give us, or 2 videos ago, I guess, pi r squared h. It's a cylinder. So we got it. Easy peasy. Woohoo. So I'm feeling pretty good about this. Hopefully you're feeling pretty good about this. If you're not, please stop the video, send me email, message me on Pronto, get my attention, ask me in class, say, hey, this isn't making sense. Can you help me with it? And I will do my best. Or go find a tutor. Tutors love when you ask questions about calculus. It's very fun to do. Okay, so you ready? Dun, dun, dun. Okay, lowly worm. This one's going to be a little more challenging. Okay. Just looking at the words, you won't necessarily know that this is more challenging, but I happen to know it's more challenging because I wrote the words. So we're going to, at every step along the way, we're going to get a little bit more challenging. So let's take a look. What if you take the area bounded by x equals 0? Okay, so let me not get caught up. Okay, so now we know, what colors did I use? Let me make sure I use the same colors just to be consistent. Okay, x equals 0, sneaky, sneaky, it's just the y-axis. Okay, trying to trick us, can't trick us. X equals h, okay. We did that one before too. Easy peasy, it's right here. Okay. The x-axis, okay, the x-axis, that one was in purple. Here we go. Okay. So far, this is looking like a rectangle until y equals x. What does y equals x look like? Y equals x is that 45-degree angle line. It's this one. Right, it goes right through the middle. Every time x goes up, y goes up. So this is the line y equals x right here. I'm going to outline it with black because I realize the yellow is just a little too yellowy. Okay, now, what's the area we're looking at? And the answer is the area is this. That's a little more exciting. And we're going to rotate it about the x-axis. So you can say, well, I'm going to guess this kind of seems like it would be maybe a cylinder again. And you'd be very close. Let's take a look. Ah, look at that. No expense spared. Okay, what happens when we go around? When we go around, we're not making a full cylinder. This top part stays looking like a point. But what happens at this end? In fact, let me cut this. There we go. Some expense was spared originally, but let's think about it. If this goes around, what happens if we look at it on end? So if we look at it on end, as this goes around, what shape does it create? Can you see? It's creating a circle. So on this end, it's creating exactly the same circle that we were getting with the cylinder, but at this end, we're not getting, well, we're getting a very small circle. It's a point. So what does that look like? That, if we rotate it, and it's a good thing for me to remind you that math is old. Math is old, and it's oddly enough, through most of its history, has been predominantly a written language. A lot of the time, people weren't talking about it. They were sending each other letters. They were writing books and papers and reading it. So it's a very written language. Written languages don't tend to modernize as fast as spoken languages. So we still have really old words. Like instead of saying rotate around, we say about. It's just one of those quirky things. It's kind of fun. I think so, at least. Let's look at what happens. Now here, if you have ever eaten gyros, that's going to be very helpful at this moment, because I'm going to try to convince you that this triangle, and I should identify, let's see, what this is, y equals x. This is, what was this point again? This point was the point H0. Okay, so this is going to be HH. Why is it HH? It's a fair question. Why is this HH? And the answer is because this is the line y equals x. So whatever x is, y is. So they match. Okay, and I'm going to rotate this around, and I'm going to claim, I'm so sorry, Mr. Jang. It's not terrible. I'm going to claim this is going to look like this, so we're going to end up with a cone. So that's pretty cool. Now, I'm trying to remember whether it actually wanted us to calculate the volume or not. I think we're not going to calculate the volume at this point. I think this one, I just intended for us to look at the result. But I don't know. Do you guys want to try? I mean, it's not like you can argue. I mean, you can throw things at the screen, but I won't, it won't reach me. So, you guys want to try? Let's try. Let's do it. Okay. I know I've decided without you. Let's go ahead. Let's at least set it up just to see what it would be like. Because you guys know what it's going to be. If we slice it and dice it, what are we going to end up with? We're going to end up with a bunch of circles like we did before. Are the circles all the same size? No. They're going to get bigger and bigger and bigger as you move out. Okay, so we want to figure out, let's see, the volume is going to be the integral. Now, x is starting at 0, and x goes all the way to h once again. And then we got to figure out what the area of the circles is, times the width of the circles, which is going to be dx, right? It's that little width. Okay. And then you should say, oh, well, duh, that's not the hard part. This is just the formula. And I say, yeah, I know. But getting this down, that's half the battle right there. Lowly Worm is very proud of us. Next up, how do we figure out what each circle is? So the circle is going to be, this is going to be y, right, for every circle, because at every point, the radius is just how high y is. So each one of these circles is going to be pi r squared, which is going to be pi y squared, which is exactly what we were doing before, right? This is not news. So now the question is, what is y? So take a look at the graph, see if you can figure that out. What is y? And there's a big hint. I put it right in the middle. Right there in the middle. Lowly Worm is going to point it out right there. Y equals x. At every point along that line, right there, y equals x. So at every point, each circle, the radius is whatever y is, which is whatever x is. So that's pi times x squared. Okay, so the volume is going to be the integral from 0 to h of pi x squared dx. Okay, but you guys can integrate that pretty easily, right? That's just pi x cubed over 3, right? We set it up. We add 1 to the exponent, divide by the resulting exponent between 0 and h. And that's just going to be pi h cubed over 3, which is exactly what the volume of a cone is. It's 1/3 pi times the radius cubed. Isn't that cool? And when I say radius, the base radius, the radius at the base. So there you go. That's the volume of a cone. I think I went a little further than I had intended, but you know what? That's just the kind of free math we're giving out here. So bonus math. Okay, that was exciting. That was fun. A little bit scary. Lowly Worm is still here. Lowly Worm is so proud of you. I am also proud of you. We got one more to do for this video. You guys prepared? Okay, let's do it. Now this one, I copied the pictures from the book because Mr. Jang or not, I don't think I could do it justice. So I'm going to give the whole thing away. But let's take a look at this one. Let me keep that down below. Find the volume of the solid obtained by rotating about the x-axis. So again, we're going around the x-axis, the region under the curve. So now look how close this is. This is so, so close to what we just did. What we just did, right, was the line y equals x. So it's straight, so we get a right circular cone with straight edges. This is not going to be a cone. This is more like a, I don't know. It's a really pointy planter, or maybe a really pointy bathtub. Or maybe if you turn it this way, don't look at that, spoilers. It's a knit hat. It's a thought. So, why is it curved? Well, it's curved because, and this is very small, I stole it from the book. So right here, this is y equals radical x. You can find it in the book if you want to look. And so that gives us, remember the square root of x? Remember that's just a sideways parabola, right? Again, don't look at the spoilers. But a sideways parabola, x equals y squared. This is just part of it. Okay, so we've got y equals radical x, which gives us that curved piece. And then, see, I don't know if you can see, it's got this drawing of that arrow that says take it around the x-axis. Now, just for a moment, imagine how interesting things would be with this one if we went around the y-axis. Because if we did that, we would end up with something that had a big hole in the middle. And that's actually what we do next, but not quite yet. Okay, so we've got this, and we rotate it around. And again, if we look, since we're rotating, when you rotate around like this, you create discs, you create circles. And so we're interested to go from 0 to 1. So that's what it's got there. There's 0, there's 1. So the question is, what's that point right there? And if this is the square root of x or radical x is 1. That's going to be the point 1, 1. Okay, so we've got the point 1, 1 here. So of course this down here would be the point 1, negative 1, since it's going to the other side. And so we've got this beautiful drawing I stole from the book, and it says sketch a typical approximating disc/cylinder. So the book and I have, we had different instruction, and so we disagree about whether this is a disc or a cylinder. It can be seen as both. It's either a very, very short cylinder or it's a disc. So it's up to you, whichever way you want to look at it. I'm going to add up all of them. I'm going to go from x equals 0 to x equals 1. And the radius, which is y, is the square root of x. So my area of each of these cylinders is going to be pi r squared. Have you caught on? It's going to be the same thing every time. Hopefully you're starting to go, oh, this is just a formula. Yeah, it's a formula. Or if you can't remember the formula, you just remember the area of a circle. R squared, which is pi y squared, which is actually, right, we started talking about square root of x, and everyone's like, oh no, whaley. And in fact, it's not that bad because we're going to square it. It's just pi times x, which is really cool. And so if we're going to, that's just the top, right? That's the area. What we're going to have to do is then stick in that width, which here is delta x, but by the time we get it into integral form, we'll call it dx. And then, dum, dum, dum. So how do we integrate this? Well, it's up to you. If you really want to, you can move the pi outside. It's just a constant. So when you integrate it, you can just leave it attached, raise x up to x squared, divide by 2, and evaluate between 0 and 1. So that's going to be pi times 1 squared over 2 minus pi times 0 squared over 2, which is going to be pi over 2 minus 0, which is pi over 2. So even with a really scary, ooh, it's the radical x, ooh, it's a parabola, notice that when we rotate it around, we end up with something that's not that hard to integrate. What do you think? Kind of woohoo? Okay. So again, we're getting in 25 minutes, so I'm going to stop this video. We still have a couple more videos to do from this section. There is a lot going on in this section, so give yourself extra time to understand it. At this point, you could choose to stop watching videos and to start some of the homework, because we have covered all of this type of homework. So the first couple problems will be just like this. Do the homework, set it, make sure it makes sense, and then go on with the rest of the videos and then work on that homework. Or, I mean, you guys get to choose. If you want to do all the homework at the same time, do the homework at the same time. Your choice. But I will be back with the next video. Again, I think there'll be probably 2 more for this section. And, but 25 minutes, that's a lot of screen time. Give yourself a break. Focus on something far away. Maybe, take a nap. Get something to drink. Know that I and Lily Worm are so proud of you, and hope you have a really good rest of your day, and we'll see you in the next video. Woo! Math on.